All right. Thank you for joining us today. We're thrilled to have you here for this exclusive technical walkthrough for Volks Finance. We're very excited to be joined by Gidon from Volks Finance, who will be showcasing the impressive updates and the key improvements they've made to their code base after the first successful boost with Immunefi. I'm Daniel from Immunefi, and later my colleague Artem will help us to guide through this exciting session. What's the purpose of this walkthrough? This walkthrough builds on the great success of Volks Finance Boost, which ran from July 16 to August 6. And during that time, several vulnerabilities were identified and promptly fixed, leading to a strengthening security posture. So Volks Finance is now doubling down on their commitment to security with a mitigation audit. And we want to extend a huge thank you to all the brilliant security researchers who contributed during the boost. For this mitigation audit, which is open until September the 5th, Volks Finance has allocated 25K in rewards. And if you uncover any new vulnerabilities, make sure to submit them using the premise of impact. Now, without further delay, Gidon, over to you.
Yeah, thank you, Daniel. So like Daniel mentioned, we ran a Immunefi boost just a couple of weeks ago. And because of the issues that were uncovered, we thought it was best to do another boost to check the fixes we made, whether not only whether they fixed the underlying issues that were found originally, but also if they introduced any new vulnerabilities. So I'm going to share my screen, and we're going to go over some of these issues that were found and the fixes we made. I think you should be able to see this. One thing I would like to add as well is that even if you didn't participate in the previous boost, then that doesn't stop you from participating in this boost. It may be initially a slight higher learning curve, but if you just go through the documentation that we provide, as well as we did a technical walkthrough for the previous boost that you can find on the Immunefi YouTube channel, that should help you get going. So some of the issues that we found can all be found in our GitHub repository that we've linked in our Immunefi boost page. And we list here all the issues that were reported, and linked to the issues are the fixes that we made via pull requests. So the first pull request that we're going to review is this one over here. So the issue that this was trying to address was that when we have a bridge router, so if you recall, a bridge router allows us to hide the complexities between the different messaging protocols that we use in our protocol. So we use Wormhole and Chainlink CCIP for sending and receiving messages. And the bridge router abstracts away the differences between Wormhole and CCIP and provides a common interface for our smart contracts to use. So you would say, send this message, and you direct it to use a certain adapter, whether that be Wormhole or CCIP, and the bridge router would forward that message to that underlying adapter to send and receive. So one issue that was reported to us was that when we added a bridge, an adapter with an adapter ID 0, in that case then, you could fabricate receiving a message. And this was because in the bridge router, when we receive a message, what we did was that we checked whether the message came from an initialized adapter. But in this case, if the adapter ID 0 was used, then adapter initialized will return true, even though, and this was because what we did was that we have, I guess, two mappings here. One is a mapping from the IDs to the adapters, and one mapping is the adapters to the IDs. So when we receive a message from a smart contract, if it wasn't known to us, then it will return to us an adapter ID of 0. And if the adapter ID 0 was returned and it was added to us, then it would be seen in this mapping over here. So the way we fixed this issue was that we check over here. What we changed was that instead of checking whether the adapter is initialized, we checked whether the adapter matches the corresponding adapter. So if we saw, if we encountered a smart contract that was unknown, it would return to us an adapter ID 0. And then when we would check which adapter ID 0 corresponded to that adapter, it would fail the check to whether it was the same adapter as the one that was called. The next issue that we're going to explore is number 25. Let's look at the pull requests. So one optimization we did was that when a message failed to be received in an adapter, then what we were doing was that we were saving the whole entire message that was failed, as you can see over here. So when we receive a message and for whatever reason it fails, maybe you're depositing some USDC and the deposit cap becomes exceeded because multiple people are depositing at the same time, then we would save the message as failed, so it could be retried later or cancelled, so that you could get back their funds. And the way we were doing this was that we were saving the failed message in a mapping, and we're saving the whole entire message. But this message is quite large, so when a message was failing, it was consuming a lot of gas. And this could lead to lots of problems, because when a message failed unexpectedly, then if the user didn't have enough gas to even record this message has failed, then instead of saving the message as failed, the transaction would simply run out of gas. So to solve this issue, what we did was that we now decide to save the message hash in the failed message mappings. And when you try to retry and reverse a message, we simply request the user to pass in the original message that was received. And we validate that the message received that the user is passing is the same message hash as what is saved in the mapping. The last issue that we're going to explore in the bridge router section is the permissions retry and reverse. So quite a few of the issues reported to us was griefing, where you can imagine that a user, like, let's say, tried to borrow 10 USDC and it failed because their loan, the prices changed and the loan didn't have enough sufficient collateral to borrow the 10 USDC. In that case, the message we saw would be saved in the failed messages mapping, and the user could later retry and reverse these messages. But these retry and reverse or retry and cancel operations were permissionless, meaning anyone could call retry and reverse on behalf of another user. The idea behind this was that we wanted it to be that we could maybe like build a system on top of it so that a user doesn't need to manually retry and reverse a message. They could, I guess, delegate that to another entity to do it on their behalf. But this leads to some griefing impacts, because if a user wanted to borrow funds 1 year ago and it's just sitting there in the failed messages, like, anyone could then come on and retry that message and potentially impact the user's loan when they no longer actually want to still perform the same action. And there's a similar issue described with cancelling as well. The user wants to have control as to when they want to cancel a message. So overcome this problem, we instead make the retry and reverse permissioned. So only the user can retry and reverse their own message. In addition, to ensure that we could still have this feature that I mentioned where you could delegate this retry and reverse to another entity so the user doesn't have to manually do the retry and reverse themselves, we implemented it so that we verify the caller has permission on the hub. And what this means is that you could be the user that originally submitted this operation, or alternatively, you could be a delegate. So one feature we had in that we still have is that you can delegate certain addresses the ability to control your account. And one of these powers that a delegate has is the ability to retry and reverse on someone else's behalf. So we can still have that functionality through using this delegate system. On the account management, we also made a couple changes there. The first change we're going to see was a relatively straightforward one, which was that if you invited an address to join your account, what we were doing was we were checking, does the account already have an address invited or registered on that specific chain? And if it did, we would revert, because we didn't allow you to have more than one address registered or invited for a given chain. And one potential issue with this was that what happens if you invited an address to your account, but they never accepted the invite? Then you had to rescind the invite before you could send an invite to a different address again. So to simplify that logic, we instead just allow you to override an existing invite if it exists. We also changed another thing with the account management, which was that before, if you could, so an account, if you recall, is many different addresses on different chains all come together to make up an account. So we have over here an account is a mapping between an account ID, which is the identifier for the account, and all the chains that the account has an address registered in it, as well as the address of the account. And what would happen was that you could unregister all the addresses from your account, and if you did so, then no one could access your account anymore. So if a user had deposits and they ended up unregistering all their addresses, they would lose access to their funds and they wouldn't be able to recover. So to change this, instead, we now record the number of addresses registered to a given account. And if you were to try and unregister your address, we ensure that there's always at least one address registered. And this means that you can no longer lock yourself out of an account. So that's everything with the account management. Next thing we're going to talk about is the logic of the lending protocol. So we're going to pull up two pull requests for this. So the issue that was discovered by the White Hat was that there could be an infinite interest rate through not checking the utilization ratio. So the utilization ratio determines interest rates. The idea is that if more of the liquidity in the pool is borrowed, then the utilization ratio increases, so we want a higher interest rate. And the utilization ratio is defined as like the total borrows divided by the total deposits. And if you think about it logically, you can't borrow what isn't deposited. So this number should never exceed 1. However, we weren't correctly implementing this logic, and you were able to have a very high utilization ratio, much greater than 1, which led to extremely high interest rates. And to solve this issue, we made 2 pull requests. The first was that when you are withdrawing, or when you are borrowing, we check that there's sufficient liquidity for you to borrow. So if there's only $100 left in the pool, which hasn't been borrowed yet, we check that you're not borrowing more than 100 USDC. And similarly, when withdrawing, if there's only 100 USDC left in the pool, then again, we check to see you're not withdrawing more than what is available in the pool. And these 2 pull requests should prevent the utilization ratio from ever exceeding 1. The next issue is about 0 deposits and 0 borrows. So there was a logic flaw in the increased collateral operation. So if we look at the implementation of increased collateral, what it did is that when a user deposits a value which is, so let's say the user here is depositing like 10 F USDC. In this case, if the deposits never occurred before, we would push to this loan collateral pools array, and we would increase the balance of the collateral. But what an attacker could do was that since we were adding to this array when the previous balance was 0, they could repeatedly deposit 0 amounts, and this would push to the array many, many times. So therefore, when they finally do deposit a non-zero amount, their collateral is counted not only for the one time they deposited, but all the times that they deposited the 0 amount. So they could basically duplicate their effective collateral and borrow a lot more than they should. We had a similar issue with borrows, although that isn't as problematic because inflating your own borrow isn't what an attacker would generally do. But in both these cases, we implemented fixes. And the way we did this was that in the increased collateral, we simply ignore the amount if you are depositing 0. And as well as that, in increased borrow, we also ignore the amount if you are borrowing 0. The next issue that we're going to discuss is the repay with collateral. So this was another logic flaw where we track the total deposits inside a pool, and the repay with collateral, the operation is that you have, let's say, 1 USDC as collateral, and you have 0.5 USDC as borrow. And you could reduce your borrow by the same amount that you reduce your collateral because they're both in the same token. So if you wanted to repay with collateral of 0.1 USDC, both your borrow would go down by 0.1 USDC and your collateral would also go down by the same amount. And when we do this operation, we need to update the total deposits because you're taking some of your existing collateral and you're using that to repay your position. So effectively, your deposits is going down. However, if you look into the actual implementation, what we were doing was that we were decreasing the deposit amount by not only the principal amount that you paid, but also the interest paid. And this was incorrect because the interest paid, I recommend you just read the description and it explains why you should no longer consider the interest and decreasing the deposit's total amount. The next issue that was discovered was the front run protection for create account and create loan. So both when you create an account and you create a loan, originally you could specify, if I go to over here, so in create account, the way it worked is that you specify the account ID that you wanted to use. Now the problem with this was that you could use an account ID, and it could be in the process of being added and finalized on the blockchain, but someone could front run you and use the very same account ID that you intended to use. And similarly, we had the same issue with loan ID, where someone could, again, front run you and use the same loan ID as what you intended to use. So to combat this issue, now the account ID and loan ID are generated on-chain using a hash of some user-denominated metadata. So if we go to the account manager, so now the account ID is a hash of the address which sent the original transaction, the chain that they're on, as well as a nonce that they provide. And similarly for the loan ID, what we do is take a hash of the account ID and the nonce that they provide. So in both cases, an attacker should no longer be able to front run them using the same account ID or loan ID, because in the case of a loan ID, the attacker would have a different account ID, so they wouldn't be able to get a matching hash. And for the account ID, they wouldn't be able to generate the same account ID because they'll have a different address and chain pair. The last issue that we're going to talk about is pull request 66, if I can find it. So this was that when you were liquidating, what we were doing was that we were checking. So the way liquidations work is that instead of repaying a debt and seizing some collateral, instead the collateral and the borrower would be moved from the violator to the liquidator. So you take on their position. And to ensure that the protocol doesn't fall into a invalid state, what we did is that we checked that the violator and the liquidator, their loans that they were using and what was going to be transferred from and to, was a match for one another. And one of these conditions was that if you're liquidating a variable borrow and you had an existing variable borrow, then that would be fine. But if you had an existing stable borrow, that would be invalid because you can't mix both a variable and stable borrow. And we weren't correctly implementing this check because we were checking whether the liquidator had a different loan position or had a different loan borrow type. So they're both stable, they're both variable. That was correctly implemented. But we had an and condition with that the liquidator had a borrow amount of greater than 0. However, it was possible that the liquidator had a borrow amount of 0, but they had some interest that still hadn't been repaid. In which case, then, although the loan types were different, the liquidator was able to transfer the debt and mix variable and stable borrow together, which led to some invalid state. So to fix this issue, we simply change this line to check not only does the borrow principal is 0, but also the borrower interest is 0. So there's many more issues and PRs that you can review. I just went through the, more complex ones, but I recommend that you view each of these as well, even if they may seem straightforward. Just a couple lines of code change can make quite a big difference.
Thank you, Gidon. Thank you so much. This was very insightful and a thorough presentation. Highlighted some of the major fixes you've implemented. Now we'll transition into the Q&A session. And for that, we have Artem, who's just joined the call and has also prepared some interesting questions. So Artem, please take it away.
Hey guys, nice to have you here. Thank you for your presentation. So yeah, I'll start with just like a few questions that we have. So yeah, I was the lead writer for Fox Finance, and I actually dealt with most of the reports that, not with most actually, with all the reports that came through Immunefi. So that's my first question about the reports you received. What kind of vulnerabilities did you find most surprising from that were received by you from the Immunefi's whiteheads during the boost?
Yeah, so the majority of the vulnerabilities were logic flaws, where we were failing to validate certain behavior. So we were thinking a lot of the vulnerabilities were going to come from the more complex parts of the protocol, the messaging between different chains and so on. But really, the majority of the protocol's issues that were discovered were regarding the lending, which is sort of isolated from the messaging between protocols. And so not only did we, implement all the fixes to the reported vulnerabilities, but we also increased the test coverage. So when we solved or when we made a pull request to fix the vulnerability, we also wrote an accompanying test to make sure that the issue was solved.
Okay, got it. Thank you. I was also interested in like you received a lot of reports, a lot of valid reports. So did you do like significant changes to your protocol, and like what changes were the most significant ones?
Yeah, so a lot of the changes were just small one-line checks. Although these can be very important and prevent critical issues. But the most significant changes were where the protocol is changing the most in terms of the amount of lines change, as well as the actual structure of the protocol, was the retry and reverse message operations. They both became permissions, so only the relevant user or a delegate can call these. In addition, you can also now override the return message parameters as well, if need be. The front run protection that we also looked at, where the account ID and loan ID are generated on chain rather than being supplied by the end user. Also saving the entire, we were previously saving the entire failed message, so now we're just saving the hash, which reduces a lot of the gas consumption. And lastly, in the account management, about not being able to unregister all your connected addresses, and the ability to also override an existing invite.
Thank you. Got it. And so maybe you have some tips for the whiteheads, or maybe some suggestions for them to identify vulnerabilities that are related to the recent fixes you implemented after the first boost.
Yeah, so I'd recommend you first review the GitHub issues that we created on the repository, because they will describe the bug, the original bug that was reported in the Immunefi boost. And once you read through that, you should be able to understand the issue that was reported. And then you'll be better equipped to review the GitHub pull requests to see whether the actual changes in code fix the underlying issue, as well as review whether it could have introduced any new vulnerabilities that we didn't consider.
Okay, got it. And apart from the GitHub, maybe you can share some resources or documentation that you would recommend for our whiteheads to learn more about your project in whole and about the updated code base.
Yeah, so we have quite a bit of documentation, which we also linked in the previous boost. So we have a design overview document, which I think is the best place to start. It's around 40 pages long and goes into quite a lot of detail as to the design of the protocol. We also did a technical walkthrough for the previous boost that you could revisit on the Immunefi YouTube channel as well, if you want to see a code walkthrough as well.
Okay, thank you. And so you mentioned earlier that you have some access control vulnerabilities found, am I right? Maybe you can describe the various access control roles that you have within your protocol and the changes you've done to them in the updated implementation.
Yeah, so the issues with the access control were really just a lack of access control, where we made some of the operations more restrictive, so fewer addresses could call these. So an example that we saw was the retry and reverse, where now only the user could retry and reverse their own messages. In addition, we also made the rebalance methods permissions as well. So you must have the rebalancer role to call these methods. And that was to prevent an issue of an attacker manipulating the stable rates and rebalancing other users up, which was a possibility.
Okay, got it. Thank you. And yeah, I have one more question to ask you. So, in what opinion do you think which sections of the code will carry like the most potential for the new vulnerabilities? Maybe some more complex parts of code, or like the overall complex implementation?
Yes, I think you can divide the protocol into two sections. One is this cross-chain communication, and one is the lending. For the original boost, most of the vulnerabilities came inside the lending. And the lending is, I guess, relatively straightforward, but it's similar to other lending protocols out there. There are a few differences, such as that we have loan types to offer higher loan-to-value ratios on price-correlated tokens. But it follows a similar model to other lending protocols in general. As well, I think the most challenging part when reviewing, though, is still the cross-chain communication, because cross-chain protocols are relatively new and there aren't many out there. So because of that, we developed our own framework for sending and receiving messages, as well as how to deal with failed messages, retry and reversal. So this is probably the most challenging part to understand, and still very important to review and make sure that there's no vulnerabilities among that.
Okay, thank you. Thank you for your presentation and thank you for your answers. Well, I'm checking right now and I think we don't have any questions from the public. Let's wait maybe for I don't know, 30 seconds. Guys, if you have any questions, please send them to the chat so I can read them out loud. And yeah, while we're waiting, I want to thank you again, guys, thank you again for your presentation and for everyone who joined the call. I think that this information that you presented and the questions you asked, this information really help our white hats to help you mitigate all the issues and make sure that all the fixes are done correctly. And yep, there's still no questions in the chat, so I think we can wrap it up.
Yes, thank you so much. Thank you, Gidon, for this excellent work through, and thank you, Artem, for facilitating the session and answering questions from the community, but more than in the community, obvious questions that might have arisen as a consequence of the first boost. So it was fantastic to see everyone attending. Just as a reminder, we set up a dedicated Discord channel for this mitigation audit. It's separate from the boost channel. So feel free to continue the conversation there, ask any further questions. I'm sure the folks finance team will be more than happy to follow up with them. So we'll be sharing a record of this session by tomorrow. Once again, thank you for attending, and we look forward to see you at the next event. Until then, happy hunting. Bye-bye.
Thank you all. Bye-bye.
Thank you. Bye.